Today we are doing Math 6, Mission 5, Lesson 9, using the partial quotients method. All right, Elena used base 10 diagrams to find 372 divided by 3. She started by representing 372. She made 3 groups, each with 100. Then she put the tens and ones in each of the 3 groups to create the diagram for 372 divided by 3. All right, so let's look and see what she did. So she made 3 groups, 1, 2, 3, because she's dividing by 3. So she's made 3 groups here. And then she's going to divvy out each of the hundreds, tens, and ones to each group. So we have the 100, 100, another 100, another 100. Okay, then we have a 10 here, there's a 10 here, there's a 10 here, there's a 10. We're going to keep going because we have 10, so here's a 10, here's a 10, here's a 10, but we haven't put this 10 anywhere yet. And then we have 2 ones. So here's 1, here's 2. The problem is we have all these other ones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones that we can't account for. Did you notice, though, that we have a 10 that we haven't placed anywhere in this diagram? Because we don't have 2 more 10s to go so that we could have a 10 and a 10 and a 10, right? We can't do that because we don't have enough 10s. So what we have to do is evenly split up this 110 like this. So what that's going to look like is we're going to split it in half, and we're going to do 1, 2, 3, 4, 1, 2, 3, 4. Now we have, instead of 110, we have 10 ones, and then we're going to see 1, that's here. Let me use a different one so you can see. 1, that's this one. Then we have this one, which is here. This one, which is there, this next one, which is there, this one, this one, this one, this one, this one, and our last one here. So now we did 372 divided by 3. The answer would be, well, you just look at one of the groups to get your answer. Right? So how many go in each group? Well, 100, 2 tens, and 4 ones. So we have 124 as our answer. Okay? Now, if we were to add up, we have 3 hundreds. We have 2, 4, 6 tens, which is 60. And then we have 4 times 3 is 12 ones. If we add that all up, it should equal our starting number of 372. So that gets us a 2, that's a 7, and there's a 3. So we have used all of the parts of 372 and equally divided it into 3 groups. So Elena's diagram for 372 has 7 tens. The one for 372 divided by 3 only has 6 tens. Why? Well, because she broke the 7th 10. Elena broke up the 7th 10 into ones and evenly distributed them. Okay. Where did the extra ones, the small ones, come from? That extra 10. All right, Andre calculated 657 divided by 3 using a method that was different from Elena's. Okay, so if we were going to do Elena's, 657 divided by 3. So let's go up here to a blank page, and we're going to do 657 divided by 3 if we were doing it Elena's way, okay? So I would need 3 groups. So group 1, group 2, and group 3. Okay? Now, I have 6 hundreds. So here we go. 1, 2, 3, 4, 5, 6. Okay. Then I have 5 tens. So here's a 10. 1, 2, 3, 4, 5. We do not have another 10. So we really shouldn't put those 2 tens in here because they can't go there. Let's keep going with our 7s, or our 1s, and see how this goes. So then we'd have 1, 2, 3, 4, 5, 6, 7. So again, we have an uneven thing. So what Elena would do is she would take these 2 tens, just like she did last time, and she's going to break them into 1s. So I would have 20 more 1s. So we would remove those from here. So now the 10s each have 1 10 in them, and then I need to continue with my 1s separating these 20. So I'm going to do those 20 in black. So the group 1 already has 3, group 2 only has 2. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And they evenly split. So we look at one group, the one group, to see what our answer is. So we have 2 hundreds, we have 1 10, and we have 9 1s. So our answer should be 219. This is the way Elena would do it. Now let's go back and see how Andre would do it. He started by writing the dividend 657 and the divisor 3. So this looks very normal if we were going to do normal division instead of division by partial products, okay? Then he subtracted 3 groups of different amounts from 657, starting with 3 groups of 200. So he knows that 3 times 200 gets him 600. So he can take 600 out of our original number of 657. So that's what he did. And he had 57 left over. Okay, so then 3 groups of 10, then 3 groups of 9. So he said, how many times can 3 go into 57? Not evenly, but close. Well, we can do 10 groups, right? See how he doesn't have to do as many as he can. He's just taking a guess. So he said 3 times 10 is 30. So 3 times 10 is 30. So I'm going to take 30 out of there, and I'm left with 27. So, and I know 3 times 9 is 27. So there's that 27 that he takes away, and then we get to 0. Andre calculated 200 plus 10 plus 9, and then wrote 219. Okay? So he now knows what he was getting, right? And you can see up here, he added straight up all of the partial products, okay? All right, so let's look. Discuss the following questions with a partner. Andre subtracted 600 from 657. What does the 600 represent? Well, the 600 represents the 3 times 200, right? 3 groups of 200. 3 groups of 200. Okay? Because Andre looked and said, oh, 3 times 2 gets me 6, but it's 657. So if I do 3 times 200, that gets me 600, which is very close to 657. It does not have to be exact. We didn't have to get as close as we possibly could. We are just taking chunks out of our whole number until we get down to 0. Andre wrote 10 above the 200 and then subtracted 30 from 57. How is the 30 related to the 10? Well, it's 3 groups of 10, and since we are dividing by 3, we're dividing 657 by 3, we get 3 groups of 10, which is 3 times 10, or 30. So that's where that 30 comes from. What do the numbers 200, 10, and 9 represent? Well, the 200 represents 3 groups. Sorry, what do the numbers 200, 10, and 9 represent? So they represent 3 times 200, 3 times 10, and 3 times 9 to get us our partial products. They're how many go in one group. So 3 times 200 gets us 600, which is the hundreds divided into the 3 groups. The 200 is what's in one group. The 10, 3 times 10 is 30, which is how many 10s in 3 groups. But up here, the 10 is what's in one group. 3 times 9 is 27, which is what's in 3 groups. But up here, the 9 is just the one group. And when we are looking at division, we want to know what's in one group, right? Or how many groups there are. What is the meaning of the 0 at the bottom of Andre's work? The 0, right here, means that we have evenly divided all of the whole into the 3 groups. So we have evenly divided the whole. How might Andre calculate 896 divided by 4? All right, so we're going to try this, okay? So you need quite a bit of room because he has stuff above his division problem, okay? So here we go. We are going to do, they don't really give us a lot of room. So we're going to do it over here. So we have 896 divided by 4. Okay, so we can say, how many times can 4 go into 8? Well, 4 goes into 8 2 times, but this is really 896. So what gets us 800? 4 times what gets us 800? Well, 4 times 200 gets us 800. So we have 4 times 2, which is 800, right? 4 times 200 is 800. And then we subtract, and that gets us 96. So then we say, how many times does 4 go into 96? Well, we could really choose anything, but let's choose 4 times 20, because 4 times 200 got us 800. 4 times 20 would get us 80. So that's close to 96. It's not the closest we could get, but it's pretty close, and that works for us. So then we're going to subtract 96 minus 80. That gets us 16. Ooh, 4 definitely goes into 16. 4 goes into 16 4 times. 4 times 4 is 16. We subtract. We have 0 left over, so we are good. Okay? Then what we have to do is add all of these up. Okay? So 0 plus 0 plus 4 is 4. 0 plus 2 is 2, and then 2. So 896 divided by 4 is 224. Okay? So partial products are just taking out bits of the whole number at a time. Okay? All right. Sorry, partial quotients. That's what I have meant to be saying. I don't know why I said partial products. It's partial quotients. All right, solve the following problems. Show your reasoning. Find the quotient of 1,332 divided by 9 using one of the methods you have seen so far. 1,000 is pretty big, and to do 9 groups, that's a lot to draw. So I am going to use this method, Andre's method, of finding partial quotients. Okay, so here we go. 1,332 divided by 9. So I see this is over 1,000, and I know 9 times 100 is 900. So I'm going to start there, because why not? So 9 times 100 is 900, and that gets me close-ish to 1,332. Okay, so that's 2, that's 3, that's 0, 13, that's 4. So I can't do a whole nother 100 because we don't have 900 there. But I know that 9 times 4 is 36. So 9 times 40 is 360. So that's good. So let me walk that through. That's 2. That's 72. Ooh, and I know my multiplication facts. So I know 9 times 8 is 72. So we'll put an 8 there. 9 times 8 is 72. That gets us 0. So now I have to add these up. So 0 plus 0 plus 8 is 8. 0 plus 4 is 4, 1. So the answer is 148. Okay. Find each quotient and show your reasoning. Use the partial quotients method at least once. Okay. So let's do the partial quotient for this one. No, let's do regular division for that one. Nope, we're going to do partial quotient for all of them because you need to see how that works. So 1,115 divided by 5. Okay, here we go. So 5, that's 11, so 10, that's 2 times. So do you think maybe 200? 5 times 2 is 10. 5 times 200 is 1,000. So that's 5, that's 1, that's 1. So that's 115. That's pretty good. 5 times what gets us 100? 5 times 2 gets us 10. So 5 times 20 gets us 100. So that leaves us with 15. 5 times 3 gets us 15. And we have 0 left. So then we add them up. That's 3, that's 2, that's 2. So 1,115 divided by 5 is 223. Okay? Now let's do this one. We have 665 divided by 7. Well, I can't do a 100 there because that would make it 700. And I know 7 times 9 is 63, and this is 66 right here. So I think that could work. So let's do 7 times 90 to get us 630. Subtract it out, that's 5, that's 3. Ooh, and I know 7 times 5 is 35. And that gets me 0. So then I add this up and gets 95. So 665 divided by 7 is 95. Okay. All right, let's do our last one. 432 divided by 16. All right, this can be a little tricky. So we can just take a number that we like to multiply by, okay? So as long as it doesn't go over this number, we're good. So we could do 16 times 10, because that's easy. You just add a 0 onto the end of whatever the number is. So 16 becomes 160, and that definitely is lower than 430. So let's do that. This is basically guessing and going, okay? So 10 times 16 is 160. That's 2. Gotta wait for my PDF to save. Then 4 becomes 3. That's 13. So that's 7. And that's 3 minus 1, which is 2. So 272. Well, I don't know if 16 goes into that evenly, but I do know that 16 times 10 is 160, which is still lower than 272. So I can do another 10. 16 times 10 is 160. Let's keep going. 2 minus 0 is 2. 7 minus 6 is 1. 2 minus 1 is 1. So I can't do another 160. So I can't do another 10. But let's just try 5. Okay? 5 times 6 is 30. Carry the 3. 5 times 1 is 5. Plus 3 is 8. So 80. So that's 2. That's 11. That's 32. Ooh, and I know 16 times 2 is 32. And I've got my 0. So now I add these up. So that's 5 plus 2 is 7. 1 plus 1 is 2. So 432 divided by 16 is 27. Okay, I want you to review your lesson summary for today. Remember, it goes on to another page. And that is all we're doing today.